All right, looking at part one of lesson 3.4 today, acceleration. And just to get you guys an update, because I know you're interested, I'm actually filming this on Thursday of our second week of being home back in September. It's been a long couple of weeks. I'm sure you're feeling the same thing. We haven't been back yet. So to just a little joy for all of us. I don't know if you can see it. We set up a Christmas tree. It's a really ugly one, but we set up a Christmas tree. It just made it a little bit brighter around here for our couple of weeks without any students. So that's that. But let's get into lesson 3.4 today because that's what we need to do. That's our real purpose. All right, so I didn't click the share screen button, so things are going to get difficult. So looking at acceleration today, and I'll do this so you don't have to look at me. Makes it better. All right, 3.4. It's a two-part one. I'm looking at acceleration. Acceleration is a change in velocity. So speed may not always be constant. Okay, so we have a slope changing. Okay, so velocity of an object may change even if the speed remains the same. We're going to get into that. Okay, so how? That's going to be what we're talking about. So that's called acceleration. Acceleration is the rate of change of velocity. All right, so velocity includes both speed and direction. Therefore, acceleration is both the rate of change in velocity and direction of that change. Okay, that's relatively complicated in the way we worded it. We'll make it simpler as we move on. So acceleration is in the same direction as the object if the object speeds up. Acceleration is the opposite direction as the object slows down. Okay, so here's a couple examples. We have some really cute drawings here. So you can see that the distance between each one of these intervals is increasing, so the object is accelerating because they're speeding up. Okay, in this case, the distance between the intervals is decreasing, so that object is slowing down, also accelerating. Now, very different than the way that we use that term in real life. In physics, this is what it means. So acceleration is a change in velocity, no matter which way that change is happening. Okay, this insect here is flying and it's constantly accelerating because it's changing direction. Now its velocity might be the same. Sorry, its speed might be the same, but because it's changing direction, it's changing its velocity, thus it's accelerating. Okay, acceleration also depends on the time interval. So to calculate acceleration of an object, divide the change in velocity by time. So here's the final velocity minus the initial velocity is the acceleration, or change in velocity divided by time. That's our formula. Unit for velocity is meters per second. Divided by the unit for time is seconds. So the unit for acceleration is meters per second squared. Okay, now you might also see it expressed as meters per second divided by seconds without the squared there. Meters per second is the way we can say that too. Meters per second squared, or meters per second. All right, so here's a problem. A race car sits at the starting line at Atco Raceway. The light turns green and the driver presses the pedal to the metal. The velocity changes from 0 meters per second to 60 meters per second in 6 seconds. What's the acceleration of the car? So remember, first thing we gotta do is find the change in velocity. So 60 minus 0 is 60 divided by 6 seconds. So this car is increasing at a speed of 10 meters per second, or 10 meters per second squared. All right, so what does 10 meters per second mean? Well, at the start, it's at 0. After 1 second, it's traveling at 10 meters per second. Okay, after 2 seconds, that car will have traveled 30 meters. So the change in velocity is 10 meters per second squared, but its total velocity is 10 meters per second. That's how the velocity is traveling. After 3 seconds, it will travel 60 meters. Velocity is 30 meters per second. Its change in velocity is still 10 meters per second. All right, next problem. A soccer ball slows down from 30.6 meters per second west, remember velocity has to have a direction, to 11 meters per second west during a 2.75 second interval. What is its average acceleration? So remember that term acceleration means a change in velocity. So it can be positive or it can be negative. So this is its initial velocity. This is its final, sorry, this is the final velocity. This is the initial velocity. So if we subtract those two, then we're going to divide that by 2.75. We're going to get negative 7.1 meters per second. So that's the rate that it's slowing down. All right. So another way that we can have acceleration is centripetal acceleration. An object traveling in a circle at a constant speed is accelerating. Why? Because it's constantly changing direction. All right. So the velocity may stay the same. Sorry, its speed may stay the same, but its velocity, remember, is speed and direction, and the acceleration is defined as a change in velocity. So if we're constantly changing direction, you're constantly accelerating. And that's the end for that one.